All right, so this is the Bouncing Ball Lab, and it's pretty straightforward. There's really not a lot to it. You're looking at different types of balls bouncing on different surfaces. So I have a golf ball and a tennis ball, and this is tile. Obviously, this is my classroom floor. What we're looking at is that conservation of kinetic energy. Now, you're not going to get a full conservation. You just aren't. It doesn't happen. But we want to get as close as we can. All right, so you've got your meter stick, and you're just going to take your ball up here at the top of your meter stick. Whoa, that's going to fall. Let's try again. You should tape your meter stick. That's probably a good idea. I can't tell if that's straight. Pretty close. There we go. Or mark it. You could just measure a meter up and just mark it. It doesn't have to be there. So you're going to take this up here at the top at 1 meter, and you're going to drop it. And then you're going to mark where it bounces, all right? So what we're looking at is when we hold our ball up here, we have a certain amount of potential energy from gravity. So gravitational potential energy. Okay. As it falls, it gains kinetic energy. That instant, right before it bounces on the floor, all of the gravitational potential energy has converted into kinetic energy. So that's going to be conserved, right? So all of this energy, this gravitational, if we calculate that, because we know our height, we can find our mass, and we know our gravitational constant. So we can determine the amount of gravitational potential energy up here and say that all of it is converted into kinetic energy at the very, very bottom of that fall. Okay? So that's how you find out how much kinetic energy we have to start. When it bounces back up, it bounces to a new height. Some of that energy is dissipated down here in the floor and in the ball when it collides. But when it bounces back up, now it has a new amount of gravitational potential energy. That was converted from the kinetic energy that it started with as it bounced back up. So to find your initial kinetic energy is from dropping it from 1 meter. Your final kinetic energy is going to be from the gravitational potential energy after it bounces. Okay, so that's how you find your initial and your final kinetic energies. Now the goal is to find a combination of floor and ball that conserves the most kinetic energy. The most that I have ever had was 86%. And I believe that was a golf ball on some type of dance surface. I'm not sure exactly what type of surface it was. But that was the most that was conserved. So that was pretty impressive. Most of it is going to be around 50% or somewhere there. All right, so different types of balls. I got a tennis ball and a golf ball and whatever kind that you can find. And then different types of surfaces. So in our bouncing ball lab, we were looking at the energy involved in the ball dropping and bouncing back up. So we had a ball. Can we see this? We had a ball up here. Okay, my pens don't want to write today. So we have a ball. I'm not sure that's going to help. And what we did was we dropped it down, right? So we have this ball that's moving down. And this is at some height. And it has some amount of gravitational potential energy to start with. So once the ball falls, that energy is converted into kinetic energy. So down here, right before it hits the ground, there's an instant right before it hits the ground, there is some kinetic energy that has been converted from the gravitational potential energy because we dropped it. So this is gravitational potential energy initial. This is our kinetic energy initial. Now what's going to happen is this ball, we'll move it over a little, this ball then is going to bounce. So after it hits and squishes a little bit, it's going to lose some of that energy. And then it's going to bounce back up. So now it's going to be going straight back up. This has some amount of kinetic energy after it leaves from the bounce. So there's a second amount of kinetic energy to start with. As the ball goes up, it's going to slow down. So it's going to be losing kinetic energy, but it's going to be traveling up. So we're going to have some other amount of gravitational potential energy. Now it just depends on where the ball bounces, right? So say this is the height of the bounce. There is a certain amount of final gravitational potential energy there. So what we're doing is we are comparing those two things. We're really comparing the amount of kinetic energies. Now we could, if we had a motion sensor, we could measure the amount of kinetic energy using the velocity, but we don't know that. So what we're going to assume is that all of this gravitational potential energy is converted into kinetic energy here. All of this kinetic energy is converted into gravitational potential energy. What that does is that allows us to calculate just using the height and the mass of our ball, and that gives us our kinetic energies. So we started the ball at 1 meter above the ground, right? So this was h1 equals 1 meter. Now once you find the mass of the ball, use your spring scale to find the mass of the ball. You can calculate the amount of gravitational potential energy it has at this point. So for the initial gravitational potential energy, we're going to use the mass of the ball, little g, and the initial height that we dropped it from. So this is going to be, I used a golf ball and it had a mass of 92 grams. So the mass of my golf ball was 0.092 kilograms. G is 9.8 newtons per kilogram. And the height that we started at was 1 meter. So if we calculate that, we have an initial gravitational potential energy of 0.902 joules. Okay. So the amount of gravitational potential energy at the top is equal to the gravitational potential energy, or the kinetic energy at the bottom, right? We're assuming all of that has been converted. So the initial kinetic energy is also 0.92 joules. Now the ball is going to lose some of that energy when it collides with the floor, and we want to find out how much. So since we can say that all of this kinetic energy becomes gravitational potential energy because it's going up, we can calculate the second kinetic energy, right? We use the same relationship, this conservation of energy, that we used up here. So the final kinetic energy is going to be equal to the final gravitational potential energy. This final gravitational potential energy is going to be equal to the mass times g times the height of the bounce. Okay, so this is our second height. So our mass stays the same, 0.92. 9.8 doesn't change. And then the height that I measured was 73 centimeters. So this was a pretty good bounce. So 73 centimeters is 0.73 meters. And if we calculate that out, we're going to take that 0.092 times 9.8 times 0.73. We're going to get 0.658 joules. So this is the final kinetic energy. This is the initial kinetic energy. So to find how much kinetic energy that you've lost, you're going to take this change in kinetic energy and divide it by the initial kinetic energy. So our change, remember, is final minus initial. And we had 0.658 joules. And we started with 0.902 joules. And so 0.902 joules. And then we're going to multiply this by 100%. And I get 27%. So I lost 27% of my kinetic energy from the bounce. So 27% of this energy that we started with was dissipated when that ball bounced.